This is the ninth of a series of short presentations that discuss some of the current myths in risk management. The primary purpose for managing risk is to improve decision making so that it makes it much more likely that any subsequent actions we take will contribute as much as possible to the achievement of our goals and objectives. It has no other purpose. However, and unfortunately, some in the risk management profession seem determined to make what are actually quite simple and useful concepts and processes much more complex and opaque. This set of presentations seeks to demonstrate how confused and confusing is the way many in the profession explain how we should manage risk. The ninth risk is concerned with how we determine the level of risk, and you will often find it said and written that it is the product of the probability of an event and its impact. Now, there are a number of problems with this statement, and yet it is often quoted in reliable texts, in learned articles and papers, and even in standards. For example, the COSO ERM framework quotes this as the method of determining the level of risk. Indeed, at times it gets confused between the level of risk and risk itself. The problems in this statement about, for example, suggesting that it's a product. Often we determine the level of risk through some other form of combination of likelihood and consequence. The second problem is the use of the word probability. Probability implies a chance per activity or per operation and is defined in terms of a chance expressed as a number between 0 and 1. And yet the people who use this type of statement really expect probability to cover frequency, return period, and all other forms of likelihood. The other and major flaw with the statement is that it's the probability of the event and its impact that is used to determine the level of risk, and that's what I want to explore a little bit further now. ISO 31000 uses the generic term likelihood, which is much wider than probability, to express the wide range of frequency, likelihood, probability type determinations. And we know from first principles that, and from the definition of risk, that to understand risk, in other words, to analyze it, we need to understand the likelihood of experiencing certain consequences, the effect of uncertainty, in effect, on our objectives. And if you think about the way we express measures of risk, typically we talk about dollars per year or lives lost per year, or what's the chance of somebody suffering this level of reputational damage over this period of time. So almost invariably we measure risk in terms of some measure of consequence per unit time or some unit of occurrence. We never express risk in terms of the underlying causal event per unit time or the occurrence per unit time. It's always the consequence per unit time. And if you think about it, really, I'm not so concerned how often I have a car accident. I'm most concerned with how often I have a car accident that leads to significant injury or significant financial loss. If I estimate the level of risk using the likelihood of me just having an accident, and that must include every time I have a minor bump or a scratch, and also the consequence of interest, which might be something severe in terms of financial loss or a major injury, then I'm going to overestimate the level of risk. So to normally estimate a level of risk, we need to take into account not only the likelihood of the event occurring that will lead to the consequences we're interested in, but also the likelihood that such consequences will then occur once the event has occurred. and normally express that as some sort of conditional probability. The simple equation on this slide demonstrates that. If I'm looking at the level of risk, which is the likelihood of the consequences I'm interested in, that is equal to, and I've shown a product here, but sometimes it's some other relationship, the likelihood of the event occurring that can lead to those consequences, amongst others, and the likelihood that it will give rise to those precise consequences. In other words, we need to take into account all the factors that influence the likelihood of the consequences and not just the factors that lead up to the event. And of course that must mean that we take into account controls, because if controls are present, then they will modify the risk by changing the likelihood of the event, by in particular changing the likelihood of the consequences we're interested in given the event occurs, and of course it will also change the nature and size, the magnitude of the consequences. That is the role of controls, to modify risk by interacting with the likelihood of the event, the likelihood of the consequences given the event, and the consequence type and their magnitude. So we can see from this that expressing the level of risk as some sort of likelihood, or worse still, probability event, and consequences that might arise from that event will lead to an overestimation of the risk. So if we do assume this erroneous statement that it's the likelihood of the event, what this means is we really can't properly represent the effect of controls when we do risk analysis. We can't get into that because we're expressing the level of the risk in a different way. We also are assuming that every time the event occurs, then we will get the consequences. And if those consequences are severe, it means that every time an event of whatever magnitude occurs, we will always get the severe consequences. Every time I trip up, it could be fatal. In fact, if I do it this way, it will be fatal. And that clearly leads to an overestimation of the actual level of risk. These are called phantom risks because realistically we cannot have those consequences at that level of likelihood. It's not feasible that they could occur at that frequency or likelihood. Now, some people may think this is being conservative, but really you're just clouding your judgment and confusing the analysis. Because of this, you can't actually distinguish between risks with different effects, different magnitudes of consequence, and therefore we can't distinguish the effectiveness of different controls. Because of that, we can't test out various options for risk treatment and arrive at the best and most cost-effective solution. It just mires our decision making in mess and confuses everyone, and we end up really with not just being too conservative, but we end up with discrediting the whole process. So you see, we really have to determine the likelihood of the consequences of interest to determine the level of risk. We don't want to start with the likelihood of the event and then pluck some consequences out of the air and put those two together. Thank you.